All right, so we're on this slide. I think it's slide 9 for everybody else. Did anybody want to read this for 10 points? This is our we do problem. Nobody? Ammeter. Go ahead. Expertise.
Today we do consider a circuit with three resistors. R1 equals 277.84 ohms. R2 equals 177.89 ohms. R3 equals 397.56 ohms. Connected in a parallel with a 25.77 volt battery. Find A, the total current supplied by the battery, and B, the current through the resistor.
All right. Okay, you got a hint or a page number for me?
Hint, see page 759.
Thank you, Ms. Vernon. That's 10 more points for you. Thank you for reading for us. All right, 759 is your go-to right now for this problem. And we got to do this quickly. So if you know something about the problem to get points shouted out, otherwise I'm assuming you don't, and keep it moving. Because I want to make sure you have time to at least look at your quiz problems. Use your Google Drive to figure out what the problem is, though. You can use the search bar inside of Google Drive and type a little bit of the problem. That can help you find where your notes may be. Just a quick tip. Okay, so turn to page 760. 759 talks about the beginning of parallel circuits. We did this problem in the past, this week. So you might have notes on it already. So let's go through. Resistance for a parallel circuit, which is what we just drew in our simulation. Okay? So what is the equation? It's 1 over Req is equal to 1 over R1 plus 1 over, so you got 3 resistors, R2, plus 1 over R3. The plus dot 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 is if you have more resistors connected. So you have more branches over here. That's if it's connected in series with more parallel. I'm sorry, it's connected in parallel with more resistors. But we only got 3, so we're gonna work with this. All right, what else do we need? Well, don't forget, we need the age-old Ohm's law, right? We just cut this off and say, hey, you also need Ohm's law, but the one that uses electromotive force, like we did yesterday. So that's epsilon, or battery, as Mr. Carson would say, that battery, right, or epsilon is equal to I for current multiplied by your Req. So in order to get this one into use, we got to figure out this one. All right, known and unknowns is what people get points if you can tell me what goes up here. It's the same also as saying V equals I times R, if you don't know. All right, now we write knowns. What do we know about the problem? What is the problem telling us or giving us to work with? Oh, you got some? Okay, so what?
25.77.
You said that's electromotive force, E? That's usually Carson's answer. You can give him a chance. 5 points a week. And he says 25.77, you said? Volts. Okay, what else do we got here? But this is part 1? No, I mean like what other known values you got? R1. Okay, I thought you said part 1. R1, what is that? What is part 1? What did Daddy say? 277 points. Thank you. 205 more for Alika. 0.84. And use the symbol omega, kind of like the god of war. All right, what else do we got up here?
R3.
Well, you skipped an R, but okay. R2. 5 more. Alika's burning up these points. Come on, what else we got here? You said it earlier.
R3.
Uh-huh. 397.6. Is it 6? Oh, 4.6. I hit 4.
46.
Okay, and omega. All right. Well, that's a league. You got what? 5, 10, 15, 20. There you go. Unknown. What do we know? It's 2 parts to this problem, right? What's unknown here? What is the question asking us? No takers? So part B, part A, what are we asking for? And then there's a part B.
The total current supplied by the battery.
Yes, sir. I told. He said it's like an engineer. Total current supplied by a battery. Loud and proud, like a black engineer. Okay. There's 5 for Mr. Carson. Is there any other? What about part B? What are we looking for?
Yeah.
We got a part B? B? Nope. You did my series circuit. The currents. Yes. So that's I1. All right. Question mark amps. I2. Question mark amps. Remember, this is a parallel circuit, so the focus is now current, not voltage, on each branch or each resistor. Okay? All right, so now we got all those out of the way, we can now work on this problem, right? How are we doing on time? 12:46, we're doing awesome. So let's go ahead and box this off. We're now going to work on tackling the first step in the process, which is getting REQ somehow. Now we got all the resistors, so technically we can just use this, flip it using that -1 feature, right? Raise it to -1 and get REQ. Let's go through that. So step A is solve for REQ, right? Not one of REQ, but we're gonna get there. And to do so, we gotta rewrite this equation. So that's 1 over our REQ is equal to 1 over our R1 plus 1 over R2 plus 1 over R3, right? Well, since it's set up already for what we're looking for, we just plug the numbers in, right? So that becomes, let's just write it out, iteration. That's 1 over REQ. That's what we're looking for. Is equal to 1 over what? Well, let's look at R1. That's what Alika said, 277.84 ohms. What about the next one? Plus, I'm going to swing it down. This is all one line. It's 1 over, one last. So that's 177.89 omega. One right there. And we got plus 1 over, what we got number? 397 is R3.46 omega. Want to go there? All right. So now all you got to do is calculate what this is. Somebody will get 10 points if they can use the calculator correctly to get it.
Hurry up, Lee, before I get it.
Q.
Yeah.
What could that be?
Yeah.
Remember, all these together. So it's 1 over that number, 1 over that, plus 1 over that number, plus 1 over that number. Who has it?
He ain't got it. I got it.
You got 12 minutes of class left. Any takers? Anybody? Who's gonna get it? I see the numbers. I see smoke coming off of Alika's calculator. Okay. Quick fingers, all right.
That time was plus.
Well, it's all pluses, right? All pluses.
Yeah. My fingers moving slow.
I see. Alika's little fingers. I be
All right.
gotta be careful, man. Don't be playing with them points. Make sure the easy on you. Make sure you use the fraction button. Makes it easy. Just hit the fraction button, put the numbers. Plus. Fraction button, hit the numbers. Plus. Fraction button, right?
See, time.
Okay, I can say my head too big. I got you. That's cool. That's cool. Be that way. Oh, she smoked them. Let's see here. What she got?
0.011.
She did it right too. Yeah, okay, don't say it now. She got it right. 10 points for Alika. That's 0.0172, right?
Yeah.
So 0.012. Great job, Ms. Vernon. 0.012. We'll put omega here, but remember this is raised to negative 1 because it's still 1 over. It's not exactly what we need. So to fix this problem, we're going to use the old math technique. It's called using the inverse power to flip or rotate that fraction. So we're going to come over here and work on it some more. That becomes 1 over R and Q, right? And we'll put parentheses around that joker, and we're going to raise this to the negative 1. This is going to change it to just R and Q. Equals, well, if you did it on this side, you'll do it on this side. So let's rewrite this as parentheses 0.0, because we're going to work on it with this inverse function. All right? And that's negative 1 there. All right, don't get confused. This is a measurement. What's going to happen is this negative inverse and this negative inverse, you're going to cancel out and just leave omega. So just worry about raising this number to the negative 1. That's all you got to do. So who has this, which is our R and Q, what we were really looking for, so we can find our current? He's going to help us get total current, by the way, everybody.
83.33.
Oh, he quick. Let's see if he got it. That sounds about right. Mr. Carson, you're awesome. 83.33. Ohms, sir, you didn't say that. Ohms, kind of like you're meditating, right? 9 minutes left. Let's hurry up. 83.33 omega. Box that because we're going to use it for our total current. So next step, let's call this step B, right? Making progress. Solve for, and we call this what? I total, right? Total current. This is before it goes down the branches. Okay, so to do so, let's use what we know about electromotive force from Ohm's law. Well, that is epsilon, that weird looking Greek E, is equal to I, which is your I total, multiplied by R cubed. Now, no sweat on this because we have electromotive force, we have R cubed, we figured it out. We just gotta plug everything in. But first, we gotta manipulate it with algebra. So to do that, we'll rewrite the equation and we gotta solve. Who can tell me for 5 points what to do here to get I by itself? She jumps up, I think she got it. Yes. Divide by what, girl? Yes, ma'am. She didn't say I, you trying to throw off. She jumped up quick too. So again, R and Q. There's multiplication, the obvious thing in the algebra is to do the opposite. So what we do to one side, we do to the other. And thanks to Lucas' help, we can cross out R cubed. Our new equation, we plug and chug, right, is going to be I total, really, is equal to epsilon divided by your R cubed. Let's plug and chug and finish this part off. I'm going to do 2 of the I's with you. The third I you have to do, and that's the current across that third branch, R3. So what does this become when we do this? This is going to now be I is equal to, let's write it out, our voltage or electromotive force was 25.77 volts, right? Divided by, what was our REQ? It's right here. Mr. Carson did this part. And someone can get 10 points, they know what I is going to be when you punch it in the calculator. Use the fraction button. It's really easy if you do it that way.
They always trying to cheat, bro. They make my calculator. So,
Really?
Yeah. But they said 25 point what?
25.77, like we said earlier.
Divided by who?
What you told me, 83.33, sir.
Got it really?
She shook her head. What do you got? Y'all got 7 minutes of class
I
left.
got 0.309.
Is that right? Let me just take a look. There's 10 more for you if you got it. Yes, sir. You know how to use that E button now. I'll tell you. 0.309, very good. 0.309 amps. So this becomes 0.309 amps. All right, real quick, I'm going to do, like I said, 2 of the I's and you gotta do the third I. How do I get that? Well, don't forget, we got Ohm's law up here, right?
Right.
So all we gotta do is use what we know about Ohm's law. Except this time, instead of saying REQ, just call R1 or whatever. So the first one, using this equation again, or the final step is step C. Solve for I1, I2, and don't forget about I3. Okay, so how do we do that? Well, use what I told you. For your I1, use this equation. So that's electromotive force is equal to your I1 times what? Well, that makes sense to use R1, right? Do some algebra real quick. Get I by itself. You already did this, so let's rewrite it. It's electromotive force I1 times, and Lee can help you out with this one before. So to get rid of it, do what she did. Drop the R1 off by dividing. Cross out. And now you have I equals, right? So I now equals, or I1 equals, electromotive force divided by R1. Plug the number in. And that was, again, 25.77 divided by your R1, which was this, 277.84 omega. So I1 is what? Leave that there for a second. Don't forget you have an I2 and an I3. So I can rewrite this as what? How do we get?
I1 is
You got it?
0.09
Amps, right?
Yeah.
Okay. Say is just what? So I2 is equal to, again, 25.77 volts divided by, what was your R2? Come over here, it's 177.89.
And it's equal to 0. It's a 4 behind it, so to get that, but it's 14.
Yeah, the same thing with the 4 behind it. It's not over 5, right?
Yeah.
So what do you got?
0.13.
0.13?
14.
Okay. And amps. All right. You got to do I3 on your own, ladies and gentlemen. You know the equation for it. You're just going to say, hey, electromotive force over R3. Figure out what I3 is, and that's all. You have until effectively, you got 10 for that too, Aaliyah, don't forget. So it is 3 minutes of class left. Try to get as much as you can. This recording will be available, like I said, in SB. I'll try to post it in the messages. Come to class tomorrow if you didn't finish it, but you got till 4, turn everything in. You do problems, that's the bulk of it. These notes, yes, the recording will have it. And of course, what else? Your exit slip, all one assignment turned in before 4 p.m. It's a quiz grade, so please try to do both questions. At the bottom, you have notes on it. I didn't give you nothing that you didn't see, okay? All right, so let me stop this. Let's get ready for our next period. I gotta scrape this video from Facebook later.